Hello everyone and welcome to Pepcoding. I hope you all are extremely good. So today in this video we are going to discuss the solution of our next question, that is copy set bits in a range. So in this question we are given two numbers A and B, and we are given two more numbers left and right that are representing a range, right? So we have to set bits in B which are set in A lying in the above mentioned range. So the bits in a given range, the bits which are set in A, we have to set that bits in B also, right? So we have to update our B. So let's understand this question with the help of an example. So let's suppose our A is 1 0 1 1 0 0 1, right? B is 1 0 0 0 1 0 0, right? So we have to update our B. So what should be our answer? We have to update our B. So let's suppose the range is given as this is our left, this is our right. So we have to update the bits in this range only, right? So rest all bits remain same. So these three bits remain same because these are out of the given range, right? So we have to update the bits in this range only. So the bits which are set in A, we have to set that bits in B also, right? So this bit is not set in A, so we have to do nothing with this bit. This bit in set is set in A, so we have to set this bit in B also. This bit is set in A, so we have to set this bit in B also. This bit is not set in A, so we have to do nothing with this bit. So the bits which are set in A, we have to set that bits in B also, and the rest bits remains the same whether they are not set in A or whether they are the out of the given range, right? So we have to set these bits in B also. So this should be our answer, right? So let's understand this by taking one more example. Let's suppose right. So let's suppose two more bits are there, right? So this is our 1, this is our 0 1 1 0, right? So let's suppose the range is given as this is our left, this is our right. So we have to change the bits in this range only, right? So we have to update the bits in B in this range only. So rest all bits remain the same. So this one will remain same, this one will remain same, right? So the bits which are set in A, so this bit is set in A, we have to set this bit in B also. This bit is not set in A, so this will remain unchanged. This bit is not set in A, so this will remain unchanged. So this bit is set in A, so set this bit in B also. So this will set in B, so this bit will change. Now this bit is set in A, so set this bit in B also, but this is already set, so nothing to do with this. Now this bit is not set in A, so nothing to do with this bit, right? So this should be our answer. So in the given range, the bits which are set in A, we have to set that bits in B also. Otherwise, if the bits are not set in A, so copy that bits as it is, and the bits which are not in the given range, copy that bit also as it is, right? So we have to produce this output, right? So how can we achieve this? From this you can see that we want the bits in the given range only, right? So in A we want the bits which are in the given range only. We have to do nothing with the rest of the bits, right? So we want these bits only, right? So if I produce a mask, if I am able to produce a mask like this, that is 1 2 3 4 5 6 3 4 5 6, right? So these are the bits of A which I want, right? If I am able to produce this mask and I perform a OR operation of this mask with the given B, so what we are going to do, the OR operation, right? So OR this mask with B, what will get? 1 1 1 0 1 1 1 1 1. right? So we are able to get our desired output, right? So these two are same, so this will be our answer. So we have to produce this mask in which only the given only the required bits are present, all other bits are zeros, right? So now our main task is to get this mask, right? Now then we will perform the OR operation of this mask with B and we'll get the desired output, right? So how we will get the mask? In order to get that mask, we have to produce one more mask. So in this mask, the bits which we required in a given range, we will produce that bits as the set bits, right? So if I am able to get this marks in which all the bits in the given range are set bits, I will perform the AND operation of this mask with A. This is our A, right? So perform the AND operation, right? So the output is, the answer result of AND operation is this. Sorry, we are performing AND, right? So result of AND operation is this. So I am able to get the desired bits which are in the given range of A in my mask, right? So in order to get my this mask, that is the required mask, I have to produce this mask, right? So how can we achieve this? We will also discuss that why we are performing the OR and the AND operation, right? So first of all, let me take a binary 1, right? So a binary 1 will be like this, right? So next we will do what, that this is our mask, right? So shift this right shift this mask by how many bits? That is the given range. So the given range is 1 2 3 4 5 6. So right shift this mask by 6, right? So we will get 1 2 3 4 5 6, right? So we will get this, right? So if I right shift the binary 1 by the given range, I am able to get this, right? Next is subtract 1 from this mask. So up till now I right shift my mask by say, now subtract 1 from this mask. So you will get here 1, right? So now I am able to get the number of ones required, that is 1 2 3 4 5 6. I am able to get 6 ones, that is 1 2 3 4 5 6. Now only what I have to do to produce these zeros, right? So simply we have to right shift this mask by how many bits? 2, right? So this 2 is what we can get, this 2 from our this range, right? So right shift again. Up till now we have performed these operations, right? Now right shift again this mask by 2. So now we will get 4 5 6. Now this is our mask up till now. Now in order to get the desired mask, we were performing what, that we were performing the AND operation of our A with this mask, right? So our A is 1 0 1 1 0 0 1 and 1 0, right? So perform the AND operation. This is our A. So the result of AND operation is 0 0 1 0 0 1 1 0 0. Now why are we performing AND operation here? Because in AND operation 0 is more powerful, right? So if I perform the AND operation of any bit will 0, it will convert that bit to 0, and 1 is less powerful, that is if I perform the AND operation of any bit with 1, I will get the same bit, right? So so in this mask we want what, that we want all other bits as 0 instead of the bits in the given range, right? So we want only this bits and rest all bits as 0. So we are performing AND operation such that it will convert rest all the bits as 0 which are not in the given range. and rest all the bits which are ones will remain the same. So we want these bits only, so we are able to get these bits which are in the given range the same as in A, and all other bits which are not in the given range are converted to 0 by the AND operation, right? So since in AND 0 is more powerful, so we are performing the AND operation of our mask with A. Now this is our required mask. Now perform OR operation of this mask with B, right? So our B is what? 11101, 11101, 0011, right? 0011. So perform the OR, right? So OR is 111011111, right? So this is our required answer, right? So these two are same. So this is our updated B, that is our answer. So we have to update B. That is our answer. So why now we are performing the OR operation? Why? Because in OR operation, in OR, 1 is more powerful, right? So if I perform the OR of any bit with 1, so it will convert the bit to 1. So it will convert that to set bit. While 0 is less powerful, so if I perform the OR operation with 0, so I will get the same bit, right? So now we want what? That the bits which are set in A, we have to convert that bits set in B also, right? So we want 1 as more powerful. Why? Because we want to set bits in B also, right? So that's why we are performing OR operation. So the bits which are set in the our given mask, they will get set in B also, right? So these bits are set in B also. Rest all the bits remain the same, right? So we want that only, such that all the bits which are set in A in the given range are set in B also, and rest all bits remain the same. That's why we are performing the OR operation here, right? So these are the steps that we have to follow to get the desired output. First, take the mask as a binary one, right shift it by the given range, subtract 1 from that. Next, right shift again it by the given left value. Next, perform the AND operation of the resultant mask with A. Next, we got the required mask, perform the OR operation of that mask with B. We got the updated B, right? So these are the steps. I hope you understand the approach. Now let's try to code this. Right. First of all, as mask, what we are taking? Right? So we are taking a mask as 1. Next, we are right shifting the mask by the given range. So right shift the mask by the given. Now given range is what? Since both the limits are including, right and left are also including. So if I write the next is here, this is the first bit, second, third, fourth, fifth, sixth, seventh, eighth, ninth bit, right? So if I perform only R minus L to get the given range, so it will give me 8 minus 3, that is 5. But the total bits in the given range are 1, 2, 3, 4, 5, 6. So we have to add one more one here. Why? Because both these limits are also included in the range, right? So that's why the our range is what? Right minus left plus 1. So our range is right minus left plus 1, right? So right shift the mask by the range, that is right minus left plus 1. All right, next step. Our next step is to subtract 1 from the mask, right? So simply decrement this mask by 1, right? So what it will do? It will subtract 1 from the mask, minus 1, right? So next step is again right shift it by the left value, right? So now since we have to right shift it by these two bits, right, these bits, so we have to take left minus 1 here. Why? Because left is 3, but I want left minus 1 bits to be shifted, right? So that's why again right shift this by left minus 1, right? I hope you understand why I'm taking minus 1 here, right? Next step is to add required mask is what? That is perform the AND with the mask, right? So next now our mask is what? Mask and A. Next we have to update B, right? So our B will be what? Perform the OR operation of the given of the required mask with B, right? So perform the OR operation of the resultant mask with B. Next print that updated B, right? So so simple code, right? So let's try to run this. So we are getting the expected output. Let's submit it. So our code is passing all the test cases, right? So what we were doing? Right? So what we are doing? We are taking one mask. We are producing one mask in which we only want the bits that are in the given range, right? Or rest all bits are 0, right? So if we are able to perform that mask, produce that mask, simply perform the OR operation of that mask with B. Why? Because OR operation will set the required bits which are set in A to set in B also, right? So since one is more powerful in OR operation, so all the bits which are set in the mask are set in B also, right? So in order to produce this mask, we require one more mask that is something like this, right? So how we code that? Simply take the binary one, right shift it by the given range, subtract 1 from the resultant. Next again right shift it by the left minus 1 value. I hope you understand why I am taking left minus 1, because I require only left minus 1 bits to be shifted, right? Next perform the AND operation. Why AND? Because in AND 0 is more powerful, so the bits which are not in the given range are converted to 0 and we got the resultant, the desired mask, right? So similarly we are performing the same steps here also, right? So I hope you understand the question, that is how to copy the set bits in a given range, right? So if you like the content, then give a like to this video. Thank you for watching.